Okay, good day to the Dr. Abba Muhammad Nizam and Dr. Nuhi Sam. My name is Patrick Lau Hon. I'm now going to present about the KNJ6333, 6233, sorry, computer apps design and application. My product is Windmill as well. Okay, first of all, I will go through the introductions. My company name is TWS, it's a Jemberhard. It's a total wind solution company that provide a comprehensive design and consultant on using wind energy to supply electrical power. Our company is certified to following standard ISO 9000-2015, ISO 14,000, ISO 2015, and ISO 45,000 in 2018. Okay, so our target client is a residential area at the Miri Seaside. Okay, and our implementation is to include the wind energy as one of the good renewable source in windmill industry. As you may see, hence this is project will cover the windmill in Malaysia, including the current regulation framework, 3D design, and simulations of the product as well. Okay, next, our scope of works is windmill structures or machines that convert the wind into a usable energy through the rotation of the wheel made up of adjustable blenders. Wind turbine, wind turbine to be important alternative to fossil fuels in the future as well. Okay, our objective is that propose a windmill that represent our company to the potential client and future direction to provide a movement best of animation. Okay, then number three, ideas to select a best material and simulation run on windmill. Okay, our motivation, impressed to learn about the operations and design of windmill, which is a renewable, which can produce a renewable source. Okay, literature review. This is the history of wind energy. Okay, so I will just go through very fast. As we can see in 2011, the wind energy provides over 12% renewable energy used in US. So we can see that 10 years ago, the US is start to use the renewable sources and is already give the 12% of it as well. And another literature review is that windmill operations. The main concept of windmill operation is to convert the wind energy into the rotation energy by set and blender. And this rotation energy can provide cutting magnetic field to give electrical power. The windmill we draw is tower windmill. As the structure of the building is taller compared to the other windmills, this allowed the sand of the windmill to be made longer. This enabled them to provide useful work even in the low wind. Okay. And methodology. Now we go to the methodology. Okay, there is 1, 2, 3, 4, 5, 6, 7. That is a 7 part of my methodology. First part is a component analysis. Okay, for in the component analysis, we have a 3 part: system component, subsystem component, and product. Okay, for system component, we have a roof, body, blenders, joining, joinder, foot, and foot. Okay, for subsystem component, of course, is about the weather and surrounding temperature and humidity. The product is the electrical rod. Next, interaction analysis. Okay, we can see that the body is holding the roof, and the roof is holding the joiner and magnetic motor. Okay, and the magnetic motor is moving when the blender is move with the wind as well. So when the blender is start moving, and the magnetic motor will produce electrical power. Okay, next. And functional analysis. Okay, functional analysis, we can see that it's most important is the blender part. Okay, the blender is very important, which affecting the blender speed, and it can produce the yellow lines, the electrical power. Okay, and the normal blue line is also useful, but it's normal. The most variable factor affecting the whole produce is the weather as well. Okay, next, cause and effect diagram. Okay, we can see that the wind power generated by the every regions will affect the body, maintenance, and heart. Okay, how does it affect the body? It's the body of our windmill. And it is important is that we need a good material and design to maintain the body so that it can be long lasting. Okay, to maintain. Okay, the maintenance of windmill is need is when the faulty or parts and also the manpower cost, which request to do the maintaining as well. And the hard part is the power generated. Okay, next. Trees method. Okay, trees method. The improving features is the power. Okay, the renewability of moving object, ease of operations, power generated. Okay, for the power, okay, for the versus parameter in the power is the loss of energy, and the inventive principle of power is a preliminary action. The renewable is the temperature, of course, is the versus parameter, and its intensive principle is priority action. Okay, the ease of operations is that worst parameter is the adaptability of versatility is 35 again, and then the inventive principle is the cementations. And the power generated, okay, the worsen parameter is the size of blender, and the inventive principle is the costing. Okay, next. Okay, Tristan method, we now to talk about power. For power, is a usable blender to reduce the loss of energy falling into the transformer by reducing the motion of the wall of the building. Okay, system parameter is power and loss of energy. Okay, the initial principle is the preliminary action addition of solar panel to improve the power generation, to renewability to prevent the object to having a high maintenance cost. Okay, for the system parameter is the durability of moving object and the temperature. And the priority action is to replace the material when it can increase the strength and withstand high force, such as the carbon fiber, alunite, titanium, so that it can lower down the possibility of fatigue. Ease of operation, try to reduce the manpower and cost of maintenance. And system parameter is the ease of operations, adaptability of versatility. Okay. Number three, the assurance principle is a simulation replacement mainframe computer by the personal computers. Okay. Next. Okay, we use the concept of design and the bug matrix to choose the best design of our windmill. Okay, the first concept design one, that is the basic operation, basic design. That is the traditional design, and we will base on then we our second design and third design will base on the first design. Is it achieve the design? So if we achieve it, then we will put a positive. If we didn't have the achieve based on the concept design one, then we will put it negative. Okay, we like look at the concept two. Okay, for concept two, both is of easy use, yes. High efficiency, definitely no. Flexible, low price, and maintenance weight is it, I consider it as plus because it's quite light and it look like it is low maintenance as well, and flexible, but is ventilation and durable is I put it as no, and it is not attractive because the wall and body part is not as strong like concept design tree. So for concept design tree, from the easy use, high efficiency, flexible, low price, no maintenance, weight, and ventilation, it is considered as a yes compared to the concept design one. And the attractive is more attractive. Okay, so the total score for the concept design tree is 7 mark. Okay, next. Okay, this is our result and discussion. For the first one, we will look at the pictures of orthographic view of windmill roof. This is a roof part. Okay, this is orthographic view for windmill blender. Okay, windmill blender. And this is the orthographic view of windmill body. And this is the orthographic view of window and door. Okay. And this is the orthographic view of windmill holder. All right, holder and join. Front part is the join. Okay, this is the exploded view of my windmill. A is a roof. Okay, A is a roof. C is the body. D is the joint and holder. Okay, D is the window and door, and then E is the blender. Okay, this is the assembly view of the windmill. All right. Okay. Now I'm going to show how we use the AutoCAD to run the animations of my windmill. Okay, we're using the Notepad by create a SCR file by writing the coding inside. So when we run it, then the blender of the windmill will be run. Okay, this is how the windmill running. Sorry, this is how the blender of the windmill rotate. This is okay. This is how you rotate. Okay, next. Okay, so I would like to talk about my FEA testing. Okay, FEA testing. Okay, for the properties of my material used on the blender is laminate structure, laminate. Okay, laminate material. So I am only testing on a blender part because most of the time it is only need to maintain to the blender as well. Only normally is the 40 on a blender part, model part. So I will use to testing the stress and displacement test on the blender. Okay, so the properties of laminate material. Okay, thermal conductivity is a 1.7 E, negative 0.1, 0.4, and specific heat is a 1464. Thermal expansion coefficient is 2.7 E, negative 0.5, Young modulus 6.89, Poisson's ratio 0.34, and yin strength and ultimate tension strength is 51.7 megapascals as well. The first picture here is the stress test. Okay, as we can see the stress test, okay, the maximum stress test is going to 0.0729 megapascal. Okay, and displacement test is 7.35 maximum. Okay, megapascal maximum. So you can see the blender start to bend already until it change shape. So this is the maximum on stress test and displacement test. Okay, next, this is my Gantt chart. Okay, so this is my Gantt chart just for your information. Okay, this is how I finished my projects from week 1 to week 14. Okay, next. Okay, conclusion. An improvement of windmill has been designed through the tricks method. 3 conception design is designed, and the best concept design was chosen by using the part matrix. Therefore, affordable windmill and was designed by reduced complexity parts and increase the ventilations. Reduce the complexity assembly part help to increase the efficiency of this product, whereby increase the comfortable of the user. And the laminate of blenders help the blendable last longer and increase the flexibility. Moreover, the materials components of conceptual design were chosen. Okay, animations of my windmill is also rendered and simulation stacks on material also chosen. FEA result is passed. Okay, recommendation: the operation stress level to works in the lower stress condition by simple cross-sectional analysis, and computer design is needed to be developed for determinations of equal measurements to achieve the correct balance. Their design should be considered balance parameters such as the curve one, twins one, taper one, completely general material and geometric. Next, aerodynamic design should be developed for wind turbo blenders so that it can be moved easily and generate electricity when blown by the wind. Okay, so next future improvement will be the blender share as well. And furthermore, the material property and design capacity must withstand the stress for much longer period. Okay, the material I would change also in our company. Okay, this is my all the reference that I used to in my report and projects. Okay, 11 total is 11 reference I used. Okay, Thank you very much. Thank you all.